Okay, so we're solving absolute value equations. Obviously, you can do it graphically. We're doing it algebraically. So remember, you have absolute value of 5. The answer is 5. Absolute value of negative 5 is also 5. Really, you're taking the negative of what's inside there. Okay, so that's what we have to consider when we're solving an absolute value equation. So absolute value of a positive stays the same. Absolute value of a negative changes sign to become a positive. So first one, we're going to solve absolute value of 3x minus 4 equals 5. Really, in doing these equations, we're going to look at different cases. So the two cases are here. If the inside of the absolute value is positive to start, that must mean it equals 5, right? Because the answer to this absolute value is 5. That must mean this is 5. But if this is negative, then we would change the sign of it to get 5. So those are our two cases. So here, and I actually label them, just case 1 is if the inside is positive, then you don't do anything. It's equal to 5. Right? So if this is 5 in here, that's the answer. That's good. If the inside is negative 5, okay, then we have to change the sign of this to get 5. So that would be the opposite of the inside to give you 5. Now you might think, well, why don't I make the right side negative 5? Sure can. You can go 3x minus 5 equals negative 5. The reason why I don't here is because we'll get to more complicated ones where you maybe have more than one term with absolute value. And so you're not going to have that opportunity to make the constant negative because there'll be a combination. Okay, so that's why I say, okay, if this is negative, what do I do to it to make it 5? I change the sign of it. I multiply it by negative 1. Now I solve these. And then I want to check to see if both of them work, if one of them works, or if none of them works. Okay, so that's how I do it. You can look at the domain of the the absolute value part, and test it that way. Once you get it again into more complicated ones, that gets more complicated. So I find it easier as a verification. No matter what, you do have to check because you could have extraneous solutions. So verification for x equals 3. And for x equals 1/3. Yeah?
I think it's x is equal to negative 1/3.
Oh, it's not even that. It's negative 1. Isn't it? Here goes over.
So negative 3x is equal to
No, it's
it's equal to 5. You said equal to 1.
Oh, that's why. Sorry. That's on my brain today. There we go. Thank you. Okay. All right. So we're going to separate. Biggest thing here when you verify, go back into the original, not back into each case. You go back into each case, they should work. Okay? You go back into the original, then you're truly verifying it for that original function. So you always keep the absolute value symbols until you actually take the absolute value, until you have just a number, one single number inside there. Okay, and then I don't keep them separate like that. They both work. So now I put them together. If you don't have the squiggly brackets, I'm okay. But you do have to put them together. So x equals negative 1/3 and 3. Now, if you just generally think about that equation and what we learned about graphing them, so the left side was 3x minus 4 in absolute value. If you graphed y equals 3x minus 4, absolute value, then it's going to be a V shape because it's linear, and the x-intercept will be 4/3. And it's opening up. So then if you think about graphing the right side, 5, it's going to go through the V twice. So that makes sense that you have two solutions. If you had something where the absolute value was equal to a negative, right? Doesn't make sense because this is a positive out front. This is always going to be a positive value, so there's no way this could ever be a negative. Okay? So just be aware of that. Sometimes you can know already before you even start solving it how many solutions you're going to have. Okay? Now, sometimes it's not just going to be as simple as an absolute value with x in it equals a constant. Sometimes it will be other variables, right? So let's see, 2. Okay. Again, kind of like radical equations. Make sure that the absolute value term is on one side, if you can. So if there's only one absolute value term, get it on one side. It is already. And then think about your cases. Okay? So x is your variable. So we actually don't know exactly what sign that's going to be. Depends on what x is. So your first case, if this is positive, when you take the absolute value, it doesn't change. So one of the cases is where nothing changes. So just basically take away the absolute value signs. The other one is if this is negative, to take the absolute value, you have to change the sign of it. So we would multiply this by negative 1. So that would be 2x minus 3 equals negative of x minus 3. Now you solve those cases. Okay, and then verify algebraically. You can kind of do it in your head, but on a test, if it's in written response, you're going to need to verify. So this first would be x equals 0. And you see that you're going to get negative 3 there. You're going to get 3 on the right, Those are not equal. Okay, so this would be extraneous. Okay, the second one does work. So again, summarize it at the bottom of all your work. X equals 2. Okay, so making it clear to me when I'm marking. Next, we're going to look at two absolute value terms. Okay, so the first situation is, so type A, let's say, no other terms. So just two absolute value terms. So let's look at an example like this. This is just to show what we do. So we're going to have absolute value of x equals absolute value of y. Y might be something in terms of x, right? We're not going to be able to tell. But let's think about our cases. So one case is if this is positive, then nothing changes. Okay? If this is positive, nothing changes. Then case 2, let's do both be negative. So if x is negative, we have to change the sign of x. And if y is negative, we have to change the sign of y. Well, look what happens. If I simplify that equation, I get x equals y. That's the same case. So the case where both expressions inside the absolute value are positive, that's one case. Both positive or both negative, right? So these are the same. Case 3, how about if x is positive, doesn't change when you take the absolute value. If y is negative, then we have to change the sign of it. And vice versa to that, if x is negative, we have to change the sign of it, and y is positive, we don't. Notice how if I rearrange this, divide by negative, it's the same. Okay, so really, you're only going to have two cases. One case, which is just the equation without the absolute value signs, and one case where one stays the same and one changes. Doesn't matter which one. You decide. Okay, so this would be example 3. So, case 1, where you just get rid of the absolute value signs. They're both positive to start. Case 2 is where you keep one the same and change the other one. So maybe I change the sign of this one, because it's only one term, and keep the other one the same. Okay, and solve those, and then verify. Okay, so the first one works. And so does the second one. Okay. So your solutions again, summarize 4 and negative 4/3, or negative 4/3 and 4. If you want to check algebraically, then I'm just going to do it from here so I don't have to double click on everything. So you could bring everything over to one side. So math, num, absolute value, 2x, cursor out of the absolute value, then subtract math, num, absolute value, x plus 4. And that means you're looking for the x-intercepts. And these these x values are between 0 and negative 10 and positive 10. So use a standard screen. And then you'll see that it crosses twice. And just check. If you think it crosses at 4, go trace 4, enter. Yep, the y is 0 there. If you think it's at negative 4/3, go negative 4 divided by 3. Make sure it's 0. Otherwise, you go second, trace 0, cursor to the left of where you think it is, cursor to the right of where you think it is, enter on that. Negative 1.3 repeating is negative 4/3. Okay, you can go into your y equals and do left side and right side separately and see where they intersect, but it ends up a little harder to read. Okay. So now the other type is type B. We'll call it, here, I'll go to the next. So type B, let's call it. So 2 absolute value terms plus another term. Either a constant or a variable, doesn't really matter. But basically you have 3 terms in the whole equation. So we're going to have to go through, in this case, we will have 4 cases. Some might eliminate. Some might not verify, but you need to go through 4. Saying that, you want to, so when I've been doing these, I've been doing the verification. There is a method where you can look at the domain of the original equation, the domain of each case, and see where they overlap. Me personally, I find it a little bit confusing. I'd rather just verify through, do that algebraic, basically it's arithmetic, to verify rather than looking at the domain and where that solution domain fits into it. So I'm going to do 4 cases and then verify algebraically. So solve here, we're going to solve value of x plus 5 minus absolute value of 3x plus 2 equals 2. And then basically you're just thinking about going through the cases. So case 1, where nothing changes. So if this was positive, when I take the absolute value, it stays the same. Same with this. So I keep brackets around what I've taken the absolute value of. Right? So if this is positive, I do this. Brackets around that equals 2. And maybe I'm going to do my case here, my verification on the right, just to, I've kind of been writing this really big. So then I get rid of the brackets correctly. That's going to be negative 2x plus 3 equals 2. So x equals 1/2. So 10 plus 11 over 2 minus 2. Okay, so that one does work. Okay. Another case is if they're both expressions in the absolute value are negative. To take the absolute value, you change the sign of them. So here, that would be the opposite of x plus 5 minus the opposite of 3x plus 2, which really makes that plus 3x plus 2. So this was a minus, and we have to take the negative of this. Subtracting a negative is adding. And then solve that equation. see this is not going to work. So we did, first case was they stayed the same. Second case was they both changed. Now the last two cases is one of each. So the first one stays the same, let's say. The second one changes, which means it would end up being an adding. Okay, because it was a subtracting to start. Question?
Hey, why did you like when you were verifying? Why did you subtract it? Why did you have to?
Why did you add it?
Oh, why did you add it? Why didn't you subtract?
Weren't you supposed to plug
Oh
it
yeah.
into
Why didn't I? I don't know. I'm not on my game today.
Because when I subtracted it, it got me 2.
Did you?
Yeah.
No.
Well, put it in the original one.
Did you?
Yeah.
Let's see. Oh, still not gonna work, but here. Oh. But yeah, I don't know why. Kind of a bad day today. I'll explain to you why. So this should be minus. This would be 15 over 2 plus 2. Because I didn't go back to my original equation all the way. I tried to use my brain, which is not working. So this will be 15 over 2 minus, that will be 19 over 2. 15 over 2 minus 19 over 2 is negative 4 over 2, which is negative 2. So it still doesn't work. So remember, because you're not, this doesn't become positive adding now. Right? Does that make sense? Yeah. So get negative 2, that's supposed to be positive 2. So still not a solution, but my verification was incorrect. Thank you for pointing that out. Okay, so then try case 3. Okay, so negative 5 over 4 does work. So that's where we kept the first absolute value the same, and we changed the sign of the second. And then the last case, usually for two absolute value terms in a constant, if they are linear inside, there's going to have to be a maximum of 2 points of intersection, but you should verify, because maybe we'll give you a quadratic or something as well. So then we're going to take the opposite of the first one, keep the second one the same, so it ends up being subtracting, because that was it subtracting to begin with, and then solve that. And based on that fact that I just mentioned, if there's two terms that are linear absolute value and a constant for the third term, which it is, it's not a variable, then likely there'll just be those two solutions. But we'll check here. And then verify that one. And the ones that did work were -5/4 and 1/2. All right, so that's our practice for solving equations. So as I said, on our timeline, that was supposed to be done tomorrow. We've done it today. So tomorrow will be a practice day. If, I don't know, if all goes well, I could have your test marked, and then that will be taking up the test tomorrow. So I'm trying to get all the IB internal assessments done, because their deadline has to be uploaded. So if I get those done, I've started marking your tests. If I finish them in the morning, then we can also take up your test. Otherwise, we'll just wait until we get back to online, because you won't have a queue for a while, right? So, and it really doesn't necessarily build on itself.